Salve, mi chiamo Patrick. Questo non è la prima volta che sono in Italia o a Firenze, però è la prima volta che faccio una presentazione a PyCon.it. Purtroppo il mio italiano è così e per questo motivo devo continuare in inglese. Scusate. So, how not to repeat yourself in the context of a REST API with Connexion, YAML, OpenAPI, and Pydantic. A short tour of what we are going to talk about in the next half hour. A brief overview of the company I work for and the project. What is Connexion and how is it supposed to be used? Why that usage leads to repetition. And then the bulk of the talk will be how we get the data we need to avoid that repetition and generate the OpenAPI for us. And then, of course, coming up with a nice and Pythonic interface. A word of warning, I will show quite some actual Python code in this talk. I hope that's okay. So, who are we? The Solute GmbH is an e-commerce company with a little over 150 people. We employ people all over Germany, but the bulk of us live in Karlsruhe in the southwest. We started out purely as a price comparison website, billiger.de. Still exists, still going strong. We get over 100 million offers from several thousand shops, and these shops then pay us for high quality traffic. That is the business model. We also provide access to these offers and further data that we aggregate via a syndication partner API, which is basically kind of like a REST JSON version of the website, except it also works internationally. And this API will be the subject of this talk. We are a Python company. There is, of course, some JavaScript on the website, but everything else is Python. So, as I said, Python company, the syndication API uses a REST framework called Connexion. In conjunction with Flask and Apache, we use Pydantic for data models and mostly Postgres for storage. There's also some Redis flying around and Solr for search. Connexion is developed by Zalando, a rather large Berlin-based fashion online shop. It's a REST framework that does request validation and provides a nice Swagger user interface which our partners can use to explore the API. It is apparently a bit more flexible when it comes to request URLs. You can do weird things. And this is a quote from the README, the Connexion README. With Connexion, you write the specs first in YAML. Connexion then calls your Python code, handling the mapping from the specifications to the code. Okay, specs first, sounds reasonable enough for an API. But we're gonna have to write OpenAPI YAML. What does that really look like? Well, okay, that's maybe a bit chatty. Let's see what we can make of this. So apparently there is a section paths, and underneath this section, there is an endpoint, looks like an URL path. The URL path contains offer IDs in curlies, resembling format string. Okay, then get is very suspicious. This is an HTTP verb, so maybe there's also post or delete or whatever. Operation ID, that is quite obviously a dotted notation module.function name. So I guess that's what Connexion will map this stuff to. Description, okay, parameters, offer IDs, we already saw the offer IDs. They were part of the endpoint path. So it's in path, as it says there. And it's a list of integers. Okay, with images is in query. So apparently it's query parameter, question mark with images, and then a Boolean, defaults to false, okay. And then there's a response, which we come to later. Okay, so what does that get offer function in the operation ID look like? Okay, That looks innocent enough. The arguments, offer ID, and with images, they will be filled by Connexion. Then we do some work, we fetch offers, we prepare images, we return some result. Okay. Except that is not the function we would write, I hope. I mean, we're professionals, and professionals have standards, right? And this is a public-facing API. So what we would write is, of course, this. See? Now, what's wrong with this? Why is this slide titled "The Ugly Truth"? Well, it is terribly redundant. See? All the red bits are the exact same information that's already in the OpenAPI YAML. So it violates the dry or don't repeat yourself principle. And furthermore, it uses type hints as type hints, and that is a bit of a pet peeve of mine because I really can't stand type hints. So we shall put them to some actual use here. So let's see if we can't deduplicate all this, beginning with the easiest one, with a docstring. So getting the docstring of a function is easy. Just use .doc on the function object, that is the bold red code. And the docstring, I'm talking about the actual string here now, the structure, the syntax, if you will, of the string, contains several parts. There's the function documentation, which itself consists of two parts, the summary and a lengthier description. And then there's the parameter description with the @param markers. So what we do is we split at words starting with an @ The function documentation is everything that's before the first @. And everything that follows is part of the param description. So the function documentation is split at the first empty line. That's the double new line at the very right of the slide. And the first part, again, is the summary, and the second part is the description. Now, this parts thing is an alternating sequence, alternating list of param and the rest of the string, param and the rest of the string. So in order to clean this up and make this usable, we get an iterator over those parts and zip the iterator unto itself, thus unflattening the list. Now we can iterate pairwise over this, and value is then the remainder of the string, offer IDs up to 100 offer IDs, this part, and we can split this at the first white space, so we have the parameter name and the actual description. And then there's this text verb dedent, which will deal with the indentation. You see, this is a docstring, this is a multi-line string, and the indentation is all wrong, and dedent will fix this. So, and now we have everything we need here, like the summary, the description, the parameter descriptions. Nice. Brief recap, like function.doc, we'll get the docstring, then the text verb dedent for multi-line strings, nice to have in the back of your mind if you ever have to process them. String.partition on a separator is a bit underused in my opinion. It's like string split with max split equals 1, but with a nicer interface because it will always return 3 values, like left of the separator, right of the separator. And if the separator isn't in the string, it will still return exactly 3 values, but the latter 2 strings will be empty. And this iter/zip thing to unflatten lists, we use it for pairs here, also works for other triples and so on. Okay, so that's already better. The red has receded. Next up are the arguments and the return value. To get to the arguments, in the inspect module, batteries included, there is a function called getFullArgSpec, which returns everything we need. The little star is the first argument here, by the way, in case someone hasn't seen this yet. This will make all further arguments keyword-only arguments. That means I need to provide the argument name when I invoke this function. Makes the interface, or our interface here, work a bit simpler. Thus, args and var args and var quarks and defaults are all none or empty. And everything we need to know is in KW only args and KW only defaults. And then there's the annotations. The annotations dict contains all the type hints, like typing.list of int, typing optional of bool. Keep the latter one in mind. And then there is a magic key return, the string return, which contains the type hint for the return type. And I think that's a very neat detail, because how could you hack this? Could you hack this? What happened if you named an argument return? Well, you can't, it's a keyword. So I think that's a very neat trick that they pulled there. Okay, again, brief recap. Inspect.get full argspec, then the star to make the rest of the arguments keyword-only arguments is a very good idea to have in mind when you have a function with more than 2 params. It's probably a very good idea. And spec.keyword-only args, spec.keyword-only defaults, and spec.annotations is what we're going to use later on. So now it's time to go to the schemas in OpenAPI speak, or models as Pydantic calls them. Remember, this was the first OpenAPI YAML slide. So the response. The response in the very last line, $ref references something somewhere else in the OpenAPI, /components, /schemas, /offer response. So this is a different part. Looks like this. This is how schemas or models are described in OpenAPI. There's this components section, subsection, schemas, and then there's an offer, which has properties. It has an ID, it has a name, it has a price. They all have types, integers, strings, whatever. They can have a description, and since this is the city of Dante, I was going to be a bit poetic with this. An example. But those schemas can also reference each other, as you can see with the offers response, which has only one property, the items, which is a list of those offers above. Okay, so this is straightforward. If, again, maybe a little chatty, verbose. Let's see how this looks in Python. As I said, in Python we use Pydantic for this, which has 2 nice effects. First of all, it checks our output for correctness and completeness. And second of all, as we will see momentarily, Pydantic can already generate OpenAPI structures for us. But first, let's a brief look at the model. It inherits from Pydantic Python base model and is composed of Pydantic fields. The first argument, by the way, for fields is really the ellipsis. This is not me omitting some code. This signifies that the field has no default value. If the field had a default value, that would be the first param. We can also add documentation, like the description and an example. Really nice. And as I said, Pydantic can generate for us the OpenAPI schema structures. There's a function called pydantic.schema.schema, which takes a list of classes that have to inherit from base model, and we're basically done. This is what this will generate. There's a little tweak. It's in the wrong place. Like instead of components /schemas, it's under definitions. So we have to refill the dictionaries a little bit. I'm gonna gloss over that. It's basically exactly what we need. So again, summary with the pydantic.schema.schema list of classes. And it's even quite easy to generate that list of classes automatically if we put all the classes in one module. Because then we can use dir on the module to get all the symbols. Dir in production code, that's weird. And get the appropriate attribute with getUtter. And then we can check if the attribute is a class and a subclass of Pydantic base model. And if this is the case, then we can include it in our list for pydantic.schema.schema. By the way, we could also have used something in the inspect module, inspect.isClass, to figure out whether it's a class. So now we almost have everything we need. We just need to add the path and the HTTP method. And we have to find out a nice Pythonic way to integrate all this, to tie it all together. So, and anyone who read the elevator pitch has already read the spoiler. What could be more Pythonic for this use case than a decorator? So this is what we're striving for. The add endpoint decorator takes a path, takes the HTTP method, and it's just wrapped around our Python code. And that's all there is to it. Now we only write Python. There's no redundancy, there's no OpenAPI, there's no YAML. That's pretty smooth. How do we get there? A brief refresher on decorators. This is the general structure of a decorator class. Dunder init creates the decorator, and dunder call wraps it around a function fn. And dunder init, in our case, will just take the path and the method and store them. And dunder call is then called with the original function, getOffers, as fn, and it can then extract whatever information it needs from fn. But in the end, it will just return an inner wrapper function that will be called whenever the original function is invoked, and the args that are intended for the original function that it will then pass along to fn, the decorated function. And this add wraps just fixes docstrings and stuff like that. So let's fill this with life. Dunder call is the perfect place to collect all the function info. We can get the docstring of the fn and process it. We can get the full argspec of fn and convert the keyword-only args into these YAML-like parameters, getting the type from the annotation. And the description from the docstring. We can check if the param in curlies occurs in the path, in the endpoint path. And if this is the case, then apparently it is a path variable. In is then set to path, and otherwise it must be a query parameter. And then we can even check if it is optional or if it's required, even though this is a bit of a hack, because we look at the string representation of the annotation and see if the string representation starts with typing.optional. That is why I told you to keep in mind this typing.optional thing. So I'm glossing over the actual get schema function, the third row from the bottom, because it is tedious. It just does a lot of if annotation is int kind of work, but it is also complicated because it has to deal with recursion and stuff like that. So I leave that for the code in the repo. I put the link in the last slide. So now we have the docs and the params. We're almost there, I promise. Let's finish this off. A path, if you remember the first OpenAPI slide, has one entry per HTTP method. This is the square braces set of method, and before that, the path. Then it has a summary, it has a description, it has the parameters, it has the module.function name as operation ID, fn.dunderModule, fn.dunderName, okay? And it has a response, whatever schema we mentioned in the type hint for the return. So now we need to collect all these information about this one endpoint into the paths module variable. And after we import all modules that have endpoints, that contain endpoints, this paths thing will then contain the OpenAPI structure for all the endpoints. So to create the Connexion app, we create an instance of Connexion.Flask app. We combine the paths from the last slide with the Pydantic schemas from a couple of slides back, and then we add all this as an API to the Connexion app. And then we run it. Et voila. All the YAML is gone, all the OpenAPI is gone, the redundancy is gone, and all the metadata we need comes from inspecting the Python code. So, to summarize, instead of writing YAML and OpenAPI, we write Python. And then we use inspection to collect all the metadata about endpoints and schemas. Thus, we get rid of all the redundancies, because these redundancies, no matter how disciplined we are, sooner or later, they will lead to inconsistencies. And also, we put the type hints to some good use, because now they are enforced by Connexion. So, that's it. I hope you enjoyed the ride. Have a nice afternoon. Buon pomeriggio.
So for the questions, we have one from Slido, and that's, what's wrong with the typing.optional? They ask.
With the typing or optional?
With typing.optional, like using that.
It's a bit using the string annotation, the string representation of the annotation, or what exactly? I'm not entirely sure I understand this correctly. The string notation, I don't think it's wrong. It's just a bit surprising. You wouldn't normally expect, like, if you have the proper type annotation, then look into the string. I haven't come across a problem with it, really.
Okay. That's the only question we have. So thank you very much, and that was a great talk.
Good. Another question?
Yeah, we just got a few other questions. Sorry about that. So, isn't it YAML good for non-technical stakeholders to follow the specification?
May I read this?
Yep, sure.
Isn't non-technical stakeholders? Oh. Yeah, you can still access the YAML. We just generate it on the fly. You can actually, the Swagger UI still works as well. Because with this, the Connexion app can still provide, and you can check this out in the source code. The Connexion app will still output an OpenAPI.YAML file for you if you access the URL. So we still have this feature. We just don't have to write it by hand.
I see. Another question is, why do you use Flask instead of FastAPI? I believe that FastAPI generates the OpenAPI spec automatically as well.
Yeah, I anticipated this question, yes. This is a historical thing, basically. So when work was started on this project, FastAPI, the very first commit was 2 months old. Whereas Connexion was already 3 years in the version 1 range. Like, that is the thing. Today, if we had to restart this project, we would have picked FastAPI, because it already has this decorator, basically. And well, now we can't switch because we are already using those more sophisticated request URLs. So we are stuck. So the best we can do is, like, lessen our pain. There's a parallel talk, like 2 rooms down, with a no-holds-barred web framework thing. This is one of the talks that I will definitely watch once they are on YouTube.
Great, thank you. Thank you very much.